So in my last video, I'd gotten up to 7/16 of total patterns of odd numbers collapsing, and I'd shown, what made up that 7/16 of patterns and why they fell apart. And I guess those were sort of the easy patterns in that, I was showing that when we had an absolute reduction in the number of digits, so if I remove 3 digits, right, and in this famous pattern ending in 101 here, I'm just saying that, well, the most I can add is 2 digits up front, so I know that I'll have at least one less digit than than before. So a number with 2 digits is obviously less than a number with 3 digits, so it has to reduce. But I wanted to be a bit more precise here rather than just sort of dealing with the easy ones, and talk about 2 more patterns that you could see with a little bit more precision must always reduce as well. So the first is this 1 0 1 0 0 and then whatever you want in the middle, 0 1 pattern. And so if we take a bit of a closer look at this, right, we're reducing 2 digits down here, right? We're removing 2. And then up here, because we have this 0 0, it acts like a sink for any carry line. So I know I have a case where I'm only adding 1 digit up front because this 1 0 1 pattern, it sort of slots together. You can just sort of see from the math, right? If I do my right, so here I got this 1 1 at the end and then something, and then if I have a carry up here, right, from the addition that's going on up there, well, that carry will follow through here, right, and then I'll have 1 1 1 1, or maybe I don't have a carry, right, and that's 0. Doesn't really matter. But I've only added 1 digit, and then when I do my +1, I'm going to have 2 zeros down here that I'm going to strike off. So I know that the number here, right, has 1 fewer digit. And the other thing about these, so it has 1 fewer digit, right? You can see how this all works here. So the other thing about the patterns that I'm building here is I was a little confused, where if you look at this 6-digit pattern, right, we have a number here. So these are all the 6-digit odd permutations. We have this 1 0 1 0 0 1. Well, this is 6 digits, and this pattern that I have here is actually 7 digits total, right? So the way I want to think about these rules is that in general, when I build this rule, the reason it applies to patterns with fewer than 6 digits is these are conditions that have to be fulfilled for the pattern to work the way it does. So I have to say that the first 5 digits of this number, right, this 1 0 1 0 0, the first, or the highest 5 place value digits of a number have to follow this pattern, and the lowest 2 place value digits of a number have to follow this pattern for it to collapse. If I want to know the total portion of numbers, with 7 digits or greater that fulfill this pattern, then I can use that little proof mechanism I've been using. But in general, for all number patterns, these are conditions that the number has to fulfill. So if you look at a 6-digit number, right, so the bottom 2 numbers here, are that 0 1, and then if I go ahead and look at the top 5, right, I see that these fulfill this pattern here. Now, obviously there's some overlap between the two, but yeah, the rule sort of holds. And then if I want to find again the total fraction of patterns, right? I can do that 2L minus 7 because I have 1, 2, 3, 4, 5, 6, 7 fixed digits, right? Over the 2L minus 2. That gives me 2 to the negative 5, which is equal to 1/32. Now, the other way I want to be a bit more precise here is we'd already looked at all these 101 patterns. So to not overlap with them, we'll only look at 001 patterns. But here we have this 1 up front, right, where we're adding 2 digits. So we have some math. And we're going to go 001. Like that, right? So we have this pattern here where we're removing 2. Then we got a 0. And then whether we have a carry up here or not, it doesn't really matter because I'll have a carry here. And so I know I'm adding 2 up front, right? So after I do the n over 2, right, I want to ask, what can I say about this number? Is it bigger or is it smaller? I know that it has the same overall number of digits, but I also know that it's actually smaller than the initial number because it's 10, right? Like if I have a number, just to take an example, like if I have like 992, right, and then I have the number 902, I know that this 0 here in this place value just below means that it's less, and that obviously holds true for binary numbers as well, right? So I can also say here that any number of the pattern, you know, this 11.001 will also collapse. And so I've got 5 fixed digits there. So I've got 2L minus 5, 2L minus 2, which is equal to 2 to the negative 3, which is equal to 1/8. So yeah, the last time we had 7/16 of the total patterns that were collapsing, or 14/32 if you want to know from last time, from all the patterns that we'd found. And then we've got our 1/32, and then we've got 1/8, which is, yeah, 4/32, right? Which is 19/32 total. So we're up to nearly 2/3 of patterns that we can show collapse, at least within a single step through the odd Collatz conjecture. So 19/32 of all odd numbers collapse. And so I think, yeah, my next tack is going to be when we look at this stuff, right? Like we've got a significant portion of these numbers. We've shown that they have to collapse, right? So we've got all of these, and then we've got some of these that after a single step generate that 101 pattern. So I think what I want to do is I want to look at the remaining patterns in here that I know grow and don't become some of the other patterns. And I want to see if they can avoid any of the significant number of patterns that we're finding. Because if we can't, and if the patterns that I have you can extend to the remainder, like if I can find, you know, that 13/32 of remaining patterns, then we'd have something interesting if I haven't made a mistake, which is totally possible because I've caught a few while making these videos. It's been a nice way to review stuff. And if you do find a mistake in my logic or in my math or whatever, it'd be super handy to have it pointed out. But yeah, I think I'll leave that for the next video since this one's nearly 10 minutes. Yeah. So 19/32 of numbers. Cool. Later.